Hi kids. So here's the lab that we've got, this reaction with iodine. So we have four things we're going to mix together. Now I'm actually going to do reaction number 2 because that one goes faster than reaction number 1. So what we're going to do in common to all of these reactions is that we're going to manipulate the concentration of 3 different things. Our 4 molar acetone, our 0.005 molar iodine, 1 molar hydrochloric acid, and water. So we're going to mix these all together, and what we're going to do by running 4 different reactions is that we're going to look at how the concentration affects the overall rate. So what we're going to do in terms of visualizing what's going to take place is that we're going to use the fact that iodine has a very distinct brownish color. So the iodine, as you'll see in the reaction when you look at the lab, gets used up. So as that iodine is getting used up, that color is going to fade out. And so as that color fades, once it goes clear, then we know that the reaction is stopped. So that's going to be our indicator, is when the reaction goes clear, that's when the reaction is going to stop. So what we're going to know is the initial concentration of the iodine, and then we're going to measure how long it takes for the reaction to stop. And then from that, we can calculate the rate of the reaction based upon the iodine concentration. Now, so the reaction itself doesn't involve hydronium ions in the reactant side. So you're going, well, if the hydronium ions aren't in the reactant side, why are we having hydronium ions as a possible concentration? This is what we talked about in the lecture from Friday. Today is Saturday, by the way. I'm filming this on Saturday. Is that the hydronium ions are a secondary reaction that's going to take place. So this is where we said, hey, you can make these intermediaries. They get used up and they get consumed. So even though the hydronium ion, when you look at the overall reaction, actually shows up as a product, what we're going to see is if the concentration of the hydronium ions actually affects the rate of the reaction. So here's going to be my procedure. Now I've already got everything measured out. So I've got my 20 milliliters of acetone. Okay, that's why I said we're going to run the second reaction. I've got my 10 milliliters of iodine, 10 milliliters of my hydrochloric acid, and then 10 milliliters of water. So if we add this all together, 20, 10, 10, and 10, that adds up to 50. So what that means is that the total volume of this solution is going to be 50 milliliters. That's going to be important when we calculate the concentrations after they are mixed. So one of the things that you're going to have to calculate is going to be the concentrations after they are mixed. So what's going to be important is that on all of these, we're going to run the reaction on a total volume of 50 milliliters. So that's going to be the common thread. Okay, so here's what we're going to do. I'm going to add the iodine last because that's what's going to start that reaction. So I'm going to add my acetone, my hydrochloric acid, and my water. Okay. So then I got the handy dandy stopwatch. Okay. So I'll start that. Didn't mean to start that. I'll start that as soon as I add in the iodine. So I've added the iodine. I'll start the stopwatch. Okay. So what we're going to do is we're going to take this and we're going to pour this into a test tube like this, and then into another test tube like this. So what we're going to do is that in an ideal world, like let's say Danae is my partner. So I would be looking at one set of reactions, and I'm going to look at this and I'm going to run this until this test tube looks like this test tube. So ideally you'd kind of look down here and like I would have a stopwatch and I would be timing it, and then Danae would be having her own set of reactions and she would be timing it, where we would run these 2 reactions completely independent of each other, where I wouldn't want to be biased. I don't want to know, hey, when are you going to start? When am I going to, or stop our stopwatches? So this way, you run this completely independent. But we can't do that, so we're just going to have to take my word for it. So what's going to happen is that we just passed a minute. So as this reaction is running, okay, what's going to happen is that this iodine is going to fade out. As that iodine fades out, then, and it gets used up, it's going to turn clear. So what's going to happen is that I've got this, just a water blank, and so basically I'm going to stop that stopwatch as soon as this reaction here goes completely clear so that it looks like water. So right now we're just kind of sitting here watching the mud dry basically. So we're doing this, we're looking down. Today we'll be watching hers, and you can tell that it's already kind of, it's faded quite a bit. And as soon as I look down that and I see that it looks like clear water, then I'm going to stop the stopwatch. And we're getting pretty close there, okay? And I'm going to stop the stopwatch. And we have about 86 seconds, okay? So at this point, the reaction has stopped because of the fact that we have, the iodine is used up. We're going to measure how long it's going to take to do this. So what I'm going to do is on the data table, I'm going to give you the reaction time for this. So that's going to be the first part of the lab. So I'm going to run all those and I'll get you that data. On the second part of the lab is that we're actually going to come up with an own combination. Again, ideally you would be in the lab and you would pick your own set of combinations. I did that for you. We're going to say, okay, based upon a calculation of rate, we're going to determine, hey, this is how long it's going to take. So we're going to have a different concentrations of iodine, hydrochloric acid, and the iodine, and we're going to predict. At that point, we're going to know our K values, and we're going to know, we can calculate the rate, and then we're going to predict how long it should take for the reaction to take place. Then I'm going to run that, and then I'll give you that data. So the third part of the lab is that I'm going to run this, and I'm going to run reaction number 2, which is what we just did. I'm going to run that at 3 different temperatures. I'm going to run it at room temperature, which is about 20 degrees. Then I'm going to heat it up, and I'm going to run it at a warmer temperature, and that reaction is going to take place really, really quickly. And then I'm going to put it in an ice bath, and I'm going to slow it way down. So what you'll see is that the reaction, when you're running it at a very, very cold temperature, is going to take a lot longer because the molecules aren't moving around as much. You don't have as many collisions. It's going to take a lot longer for that iodine to react. Then when you run it at warm temperatures, you're going to probably get it around 10, 11 degrees Celsius, something like that, on that cold side. And then I'm going to warm it up probably to about 30, 35 degrees, something like that. And then I'm going to run it then. And that reaction is going to take place really, really quickly because of the fact that now these particles have so much energy that they're colliding so rapidly that the reaction is going to take place very quickly. So what we're looking for eventually is the activation energy. So what you're going to do, and I'll take you through the actual process with lab, is I'm going to plot a temperature of 1 over the temperature in Kelvin, like on that assignment you just had on Thursday. So I'm going to take 1 over temperature in Kelvin on the x-axis. We're going to put the natural log of K on the y-axis. We're going to get a graph, and then we're going to find the slope of that graph. We're going to use that to calculate the activation energy. So here's what you need to remember. You're going to mix acetone, iodine, 1 mole hydrochloric acid, water. The reaction is going to go until it all fades out. That means all the iodine is used up. I will give you the data in the lab, and we'll go from there. So notice that I am practicing safe science. I do have my safety glasses on. I've got my official, even though I'm doing chemistry, the Mr. Physics lab coat, and life is good. So anyway, kids, I will get this posted up on YouTube. Thank you. See you. Bye.